have a confession to make. About 5 months ago, I never tested any amount of code that I ever created. I never did. If I wanted to get something done, why would I run a write test? That's twice the amount of code I have to write to get the same thing done. Why not just write it once, make sure it works in the browser, and just move on? Does that sound familiar? Well, I got to tell you too, though, I'm not here to preach. The one thing I really don't like is when I go to these conventions. Sometimes you have people saying, well, if you don't test your code, you're not a real software engineer, because real software engineers must test their code. And I really don't like people that say that that you have to be doing this. I also have a problem with authority figures in general. So I'm not going to try to preach at you guys saying you have to be doing this. I'm just going to kind of show you maybe why you should. Really lead you down the path to developer enlightenment, because there is a path. There is a path that many developers, after working in the field for 10 to 15 years, there's certain truths that they discovered. There's a certain realizations that they had, and I'm going to bring you down this path of realizations, and hopefully you'll be able to use it, even if you're not doing Rails full time. It should hopefully strike a chord, maybe give you some ideas. So let's go ahead and get this next question out of the way. When do we need to write tests? It's a good question. I'm going to answer it once and for all. So for this, I kind of figured we needed a dialogue. So here we've got DJ Ango, and he says, if my code works perfectly, why should I write tests for it? In the world of agile development, we write a lot of modular code. We reuse a lot of bits and pieces. And if you write tests for your code as you go along, you can really modify the code and improve it without breaking functionality, especially with the bigger applications. I might have a 20,000 line piece of code, and if I don't have tests for it, I've got to worry. If I change this model code down over here, well, it might break 3 different things. So even though your code might be perfect, if you don't have tests for it, you really got to worry when you make changes. So if the code works perfectly and I'm never going to change it, then why should I write tests? No software design is perfect. And when we do test-driven development, which I'll get into in a minute, you end up actually putting more thought into the design. Okay? So unless your design is perfect, writing tests you'll end up with tests that's easier to read, it's more modular, and it's clean. And I'll show you why that is a little bit later. So if the code works perfectly and I'm never going to change it and the design is flawless, then why should I write tests? Well, tests not only test your code, but it's a good way to explain how your code works. You might have comments, but really showing an example is a lot better than just showing comments. And I'll show you an example of that a little bit later too. So, oh snap! So you're saying that if the code works perfectly, I'm never going to have to change it, the design's flawless, it's totally readable and understandable, and I don't have to write tests. Yeah, that's true. If it's perfect, yes, you don't have to write tests. Of course, the moral of the story is, don't be like DJ Ango, but also, you need to write tests for your code. Admittedly, it's not something you can start doing one day. It takes some effort. It takes some learning. It's kind of like riding a bicycle. It's not easy to start. And if you're not doing it now, and you really get into software development, you'll be doing it about 5 years from now. So why not learn at this point and jump into it as soon as you can? Because once you do, you'll notice your code gets better, you'll feel like a better programmer, and your application will do a lot less of this. And if your application does a lot less of this behavior, you're going to be a happier programmer in the long run. And it really does come back to programmer happiness. A lot of Rails developers, we talk about programmer happiness. It's easier to write Rails code. You can get more done. And in the same way, really, testing increases happiness. Doesn't he look happy? It does. Okay, so now that we got that out of the way, let's dive into the how. I like doing the why. Let's do the how. And I'm going to get into the evolution of testing, but keep in mind, this whole sort of testing right now is a moving target. It's not meaning that it's not solid. People are still learning the best practices. And so a lot of people feel like it's a personal thing. You've got to figure out what works best for you, works best for your application. So by all means, don't take this as gospel. So let's jump into it. Let's jump into the evolution of testing, which is basically the pathway to developer enlightenment. First of all, testing breeds confidence. Once you start testing your code, your confidence as a programmer increases. You can deploy, a 20,000 line application to your server. You run all the tests. If you have your test suite, everything passes, you can sleep well at night. If you get that sort of confidence, you're going to have more confidence to improve your code. You're going to be able to make those sort of agile changes. You refactor your code. If you realize one day, oh, this function down here, I've got this same line of code written in 3 different places. Well, I can kind of refactor it into one function. You're going to feel confident that you can do that because you've written your tests out and you have a test suite and you know you haven't broken anything. The second realization that a lot of developers come to is if you write tests before you write your code, you end up writing better code. For example, let's say I've got this action. I've got this action which submits a credit card. In my controller, I've got an action. Once, it basically takes the input of a credit card and validates and whatnot. See if you can, just by looking at that, picture the code in your head. See if you can picture the steps. Just take a second. What would it look like in that action? Now, let's take a second and write out a specification for this. Basically, here's the steps involved. Maybe we have a specification that says a user can submit their credit card, the server attempts to charge the card, on failure display an error message, on failure render credit card info again, on success store the transaction, on success redirect to the receipt page. Now that we've written this out, now try to picture the code in your head. It should be a bit clearer now. Since we've written out the specification, it should be easier. You should be able to get it done in a smaller amount of time. What I've written here is not only a specification, but it's also showing everything that needs to be tested. If I take the time to write the test beforehand, several things happen. First, it forces you to think before you code. And if you think more about what you're doing, odds are you could come up with a better solution. My code is more focused and clear. And I'm going to know exactly when I'm finished because all the tests pass. This is, of course, test-driven development. This sort of mentality of writing out the specifications, writing out the tests first, and then writing the code. So you're going to know when you're done with it. You're going to know all the tests pass, and you're going to move on. And you'll hear people in the Rails community, when they talk about this, they'll often bring up this whole idea of red, green, refactor, which is a methodology for coding. What they mean when they say this is first write the tests. I write all my tests. They're all going to fail because I have no, I don't have the code yet. Then write code until all of the tests pass. And then take a moment to reflect upon that code and try optimizing it. So it's red, green, refactor. And then I go to my next thing and I repeat that system over and over again. So that goes back to, if you write tests before you write your code, you're going to end up writing better code. Now, not many developers actually get past this realization. Usually this is where people stay for a while. TDD is not an easy thing to do at first. The next realization is that well-written tests are just as good, if not better, than documentation. Meaning, if you write your tests in a certain way, what you end up with is not only good documentation for how your code works, you also end up with a bunch of great examples on how to use the code. So, for example, if I told you guys these yoga instructions, maybe a few of you would get it right the first time. Right, there's the directions. Some of you guys would inevitably end up doing something like this. But if I show you an example, I bet a lot of you guys would get it right the first time. An example is much more powerful than just comments. And that's what you get when you write out really well-written, readable tests. And so once you write really beautiful examples in your test, developers then realize that TDD isn't really about writing tests. It's really more about writing behavior. And this is where developers start moving away from traditional TDD and more towards behavior-driven development, which I'll define in a second. It just makes more sense. Using traditional TDD, developers end up writing one test per function. They get kind of in this rhythm where they're like, okay, I have this function. I need to write a function for a full name. Okay, I write a test, make sure I have a test for it. I'll write the tests out first for each function that I need, and then I'll code these out. But this really isn't too good because this leads us to write tests that represent the structure of the code. Tests like this are simply less readable, less clear, and they look like tests. There's no way to see the big picture, how things get used. Alternatively, let's see what happens when we change our way of thinking and try to write out some tests that identify behavior rather than functions. So, everyone's familiar with, the whole member system. You log into a member system, maybe you forget your password. You've got to hit the forget password link, which brings you to a form where you type in your email address and you hit reset password, and it'll send you an email with a link maybe that you can reset your password. So let's go through that example. So let's write out the behavior. A user who forgot their password, now I write out all the specifications just like before. Should be able to enter and submit their email address. Should be sent an email if the email address is valid. Should be sent a notice if their email address is valid. Should be redirected to the login screen if their email address is valid. Should be shown an error if their email address isn't recognized and shown in the form again. There's our specification. And using this methodology, we basically end up telling a story with specifications. And that's really behavior-driven development. Dan North, this guy Dan North, did most of the writing, most of like the inspiration for it, really got together all these ideas and kind of coined the phrase. So, behavior-driven development, what is it really? It's a lot about less writing about tests and more writing about specifications. And it's also about defining your behavior using specification-centric vocabulary. So you'll find people that do behavior-driven development, they kind of shy away from the word test. Like, test, which personally for me is also kind of has negative connotations to it. I don't want to think about tests because for me that feels like, oh, more work. So they kind of get the terminology away from the word test because we're really defining specifications. Also, it's all about isolation, which I'll get into later. And it's about testing only what you need to test, not over-testing your code. So, how do we do it in Ruby? One option would be to use what we are given, which most people are familiar with in Ruby, which is test unit. And we could use test unit to do behavior-driven development. What you might end up with is something that looks like this. Okay, now you can see here I'm using the same English that was in my specification a second ago. You've got a user forgot their password test. Test should be able to enter and submit their email, assert, and use all these asserts, all this assert crap. And really, this isn't pretty. It's not optimal. I mean, it doesn't read very well. I mean, as programmers, we're familiar with classes and functions, but is this the most readable way to write specifications? I don't think so. And the people that put together BDD, they realize this. They kind of realize that BDD needs its own language. And Dave Estells was sort of the first guy to realize that it needs its own language, and he wrote a big blog article about it. And then this guy, Stephen Baker, who's a Ruby guy, realized that he could easily take all of these, the framework that Dave Estells put forward and create something in Ruby, something we call a domain-specific language. Don't worry if it doesn't make any sense, that word. But just another language to write out these specifications. So Ruby, he wrote basically RSpec, or respect. I like it, respect. And that's what we use in Ruby to do this behavior-driven development most of the time. We were lucky enough this last 2 weeks to meet up with David Chalinsky. He's in charge of the RSpec project now, and that's the guy in the middle. So let's dive into it. How do we install RSpec to get started? Without Rails, you can install it as gem install RSpec. With Rails, we install it using 2 plugins. And then once you have these plugins in your app, you run this line, Ruby script generate rspec, and that will create some folders for you. It'll create an rspec directory and do a few things so you'll be ready to write specifications. And then we can run the specifications just by typing rake spec. Just like you'd run rake to run your normal test, you can run rake spec. It's also really important, if you're doing testing, that you run some sort of auto test. One problem I had with testing is having to remember to run the test every time I make a modification to the code, right? So I make a modification, go run the test, make a modification, go run the test. You spend a lot of time going back and forth and running tests. Well, this program ZenTest comes with this application called AutoTest. If you run it in the background of your application, every time you save a file within your application, AutoTest is smart enough to go and find the tests that have to do with that file and will automatically run them in the background. So you no longer have to run the tests every time. It runs in the background and runs them for you as you code. It makes testing fun for me. That's the leap for me, because I was like, wow, this is fun. Now I don't have to remember to run that test thing anymore. And I'll show you that, because there's lots of other plugins in here. You can integrate with Growl and OS X to give you like pop-ups. I've got one on mine. You'll hear I'll plug in the sound. I've even got sound, so I know when my tests get run. Let's see some code. Let's jump into some code. I'm going to be jumping through this example. So I'm ready to go. I've written my specs. Let's write some code.
So here we've got our Rails application. And we've already installed our rspec plugins. The next step is to run Ruby script generate rspec, which we've also already done. The Rails plugins also give you a bunch of rake tasks, which we can use here. We're going to go ahead and run rake spec, which would normally run all of our specifications, but we don't have any. So let's go ahead and start up our auto test in the background, so when we do write tests, it'll run. What you saw right there is my Growl notifier letting me know that auto test already started up and all the tests currently pass. So here we are in TextMate, and as you can see, here's the specifications that we used before in the presentation. Our next step is to take these specifications and convert them into rspec syntax. And I wrote a cool little TextMate command that you probably saw along with this blog entry that allows you to start with this, hit a command, and all of a sudden your specs are in rspec syntax. So as you can see here, we've got a user who forgot their password should be able to enter and submit their email address. But there's no test written yet. It's not done yet, as are all of the other specs that we haven't written yet. This is actually going to be for our users controller, so I'm going to specify that here. We then need to save it, and here's our application, and this goes in the spec controllers directory, and it's called users controller spec.rb. We're going to save it. You hear that? That is my test in the background. That tells me that the tests ran and they succeeded. Let's go back to that. So here we've got our tests. They ran. There was 5 examples, 0 failures, and 5 pending. And here, as you can see below here, it actually lets us know there's 5 pending specs that we need to write that are not done yet. So let's go ahead and try to write them using test-driven development. So we've got a user who forgot their password should be able to enter and submit their email address. So just let me think in my head. I'm obviously going to call the user model, and I'm going to say it should receive the find by email function. And we're going to call this action. We can do that by doing a get reset password, which is the action inside the user's controller. And I'm going to have to send in the email as well. The email here, we're just going to put joe@low.com. And I can verify that gets sent in by doing with joe@low.com. So let me save it. My test is going to run. Oh, and it's going to fail, just as we expect, because we haven't yet written this this reset password action. So let's jump into that controller, the user's controller. So the user is going to submit their email address, and we're going to want to find by email on their email address, and we're going to store that in the user variable. So if I save this, our test automatically run, and now the function gets called. So we've satisfied the first test case. Now let's go back to the user's controller spec and let's try to do a few more here, because we know that when we complete all of these, we'll have the functionality that we need. Let's do should be shown a notice if their email address is valid. So in this case, we want to make sure that after the get reset password action is called, that flash notice should be equal to email sent, because we're sending them an email to reset their password. Also, let's do the bottom one. This says should be redirected to the login screen if their email address is valid. Okay, so same thing here. We want to make it so that after the action, response should be redirect. So I'm going to save this. We haven't written the code yet, so these specs should fail, as they do. Now it's time to write some code. So we try to retrieve the user. If the user exists, then we want to flash notice equals email sent, and we also want to redirect to let's do login path. So now we save it, and if we get lucky, our test passed the first time, and they do. Pretty cool. We're going to stop here for now, but I hope this demo has given you a small taste of what behavior-driven development is like with RSpec. Now back to the presentation.
We need to go over how to keep isolated, because that's a really big part of RSpec. RSpec makes that really easy for you. So we've got model view controller. If I have tests that test stuff in the view without any sort of isolation, the view might go through a controller. It might then go through the model to get the data and work way back up if I've got tests for the view. That's not so good, because if I've got a test that's testing something in here, something breaks, well, where did it break? Did it break in the view? Did it break in the controller? Did it break in the model? There's all these dependencies. RSpec makes it really easy to separate these things. And what it does is it creates, you've got 3 different directories. You have a test for your models, a test for your controllers, and a test from your views. And it's important to keep those isolated. So in the example that I showed you earlier, we're writing a controller test, and in it we called user.findByEmail. And that then went and it hit the model. That's bad. We weren't writing isolated code. So we kind of need a way to fix that. So here was the code here that we wrote. We've got user.userFindByEmail, and we need to figure out a way to make it so that the controller doesn't hit the model. One way to do this is to create a canned answer. There's 2 tricks that we use in testing to keep things isolated. So what's our objective here? How would we satisfy using that code? Well, if we could somehow make it so that user.findByEmail returned true, we could somehow put that phony canned answer in there, just verify that it gets called, then we'd be isolated. Then it wouldn't jump out of the controller to the model. Because we really don't need to test user.findByEmail. That's part of Rails. We don't need to test that that works. Rails is already pretty well tested. We do this, make it a canned answer, by using something called a stub. So, and a stub we call by doing something like this. We say user.stub, findByEmail, returns true. If I have that in my specification, in my testing code, when my specification gets run and findByEmail gets called, it's going to return true. It overrides it. It's a stub method. It's a canned answer. Yeah, so it basically returns that. And now, when I call user findByEmail, it kind of bypasses the model and just returns true. In the test, I've got that, and now in my controller action, I've got that code, and it returns true, and it works. Now, what about, there's one other trick that we use in our spec, because this isn't good. Because here you notice, not only are we returning true, we're returning true, but then this isn't going to work here, because it's going to call true.firstname, right? That's not good. It's going to error out, right? So we need another trick here, so that it doesn't try to hit the model, and so that so it works. What we do is we need an object. We need an object, a fake object, with canned responses, and that's what a mock is. So here's the two different things. We've got these two tricks. A stub is basically a function with a canned response. A mock is an object with canned responses. Another way to look at a mock is just a fake object with a bunch of stubs. Don't worry if you don't get this right away. It's kind of an advanced topic, but you kind of have to learn it once you get into it. In order to create a mock, this is what we do. We can say user equals mock model user. It creates a totally fictitious fake object that has no functions on it. You can think of it as a blank object. We can then add stubs to it if we want. You could add a stub to it called, first name returns Gregg. Then if we tried to call first name on this fake object, it will return Gregg. Now there's a shortcut here, which what we can do when we create the mock model, we can also do this. We can also include the stubs as a list of hashes along with it. Okay, so let's declare that. So now I've got our mock model in our test code. We have our stub returns true, and then our controller code. But there's still something wrong here. Does somebody see what's wrong? This would fail still. You see where it says returns true? Okay. What we want to do here is make it so that instead of returning true, it returns the mock object. So basically when we get here, it calls user find by email. It returns the mock object, which is user. It then does flash notice user.firstname, and we call that on the mock object, and that returns Gregg, and that passes. Don't worry if you don't get that the first time around. You'll see it again. So another good question is what to test. And the way I look at it is I need to write a test for every line of code I write, but not Rails. You don't need to test Rails. If I call a find all function on a model, I don't need to test that that works. That's Rails. Rails has tests. I don't need to retest that. Here's a couple examples. If I've got validates presence of first name, here's what the RSpec code would look like. User should have at least one errors on first name. Pretty readable. If I have a has-many relationship, I might want to test that. And I can do that just by saying user.userRoles create role admin, and then verify that the count on user roles for that user equals 1. If I have a redirect to, you guys kind of already saw this, I test that response should redirect to action index. So, lastly, how to get started on this. If you're ready to jump into it, you have a new project in front of you, I really recommend taking the time to learn this and start doing it. It's really rewarding, especially if you get auto test built in there at first. The first step would be to just simply read the RSpec website. It's probably one of the best written like tool websites out there. They've got great examples. They lead you through it step by step. It's just as good as reading a book, and it's your reference guide. It's awesome, and that's all you need to know is just read the RSpec website. You'll get it. Then I would say just start a new project. Go for 100% test coverage, and that's that archive thing that I showed you guys briefly. So every time after you run your code, you're all test, you're done coding for the day, go run archive, make sure you're covered. If it's not, add a few tests. Feel really good about yourself when you've got 100% test coverage. I would also say have the discipline, keep all tests passing. Like for me, I give myself a hard time. I don't let myself leave be done for the day until I've checked all my code into Subversion. That's what I would have said 5 months ago. I don't let myself be done for the day until all the code is checked in to the source code repository. I've then taken that a step further now. I don't let myself be done for the day until all the tests pass. And then someday, hopefully soon, it's going to be I'm not going to let myself stop coding for the day until it's 100% test coverage. But, baby steps. So that's about it. Any questions?